We're going to be going into some detail about random variables and expected value. This is a more or less new concept for us. So I want you guys to think about this. This is our example that we're going to be doing. So an insurance company offers a death and disability policy that pays $10,000 when you die, or $5,000 if you're permanently disabled. Think if you're like lose a thumb, or like if your arm gets cut off, or something crazy happens to you, you get $5,000. It charges a premium of only $50 a year for this benefit, so that's not bad. Is this company likely to turn a profit? So, if this was your company, would you turn a profit? And I just want to put this into perspective. $50 a year for this plan is only about $4 a month. So, like, think that's something that I don't know. I would probably buy that. To answer this question, the company needs to know the probability that its clients would die, though, in any given year or get disabled, which is kind of creepy. But people literally get paid to do these types of things, and they get paid a whole lot of money. So, what we're going to be talking about is random variables. So, a random variable is a numerical value based on an outcome of a random event. So, something that we can't really plan for to happen. We use a capital letter like X to denote a random variable, and then we denote the particular value that it can have by the corresponding lowercase value, in this case X. Sorry about that typo. Okay, so the amount the company pays is our random variable because that is the numeric amount. Okay, so for example, the insurance company, little x can be 10,000 if you die, 5,000 if you become disabled, or $0 if nothing happens to you. Okay, so suppose, for example, that the death rate in any year is 1 out of every 1,000 people, and that disability is 2 out of every 1,000 people. And then we can display this in a table like this, okay, where this is the outcome. So these are basically things in the sample space, so the things in the Venn diagram. And then this is the amount that's attached to it. So now what we're doing is we're saying actions have outcomes, which is true, right, of life. Like, for example, if it rains, flowers grow. Or if it snows, we have snowman, right? If we die, we get $10,000, or someone we love gets $10,000. If we get disabled, if our thumb gets cut off, someone we love gets $5,000, we get $5,000, right? And then the probabilities are attached to these. There's likelihoods to these events, which means there's likelihoods to these amounts of money or things happening, okay? So this is when we get into an idea called expected value. So expected value is a probability that the calculation is expected value of a probability is a calculation of what we can expect to happen in the long run given probabilities of their events and their values. Okay, sorry about that. We denote expected values in two ways, which is e to the x, or e, big E of x. And then it's easy to calculate expected values of a random variable. You just multiply every possible value by the probability of the event's occurrence, and then you find the sum. Now we denote that in this equation here, which is e to the e of x is equal to the sigma x times p of x, which is the amount, right, or the value of the value of the event times its probability, and then we're gonna add them all up. Okay, so this is our example here where we have death, disability, and neither, paying out 10,000, 5,000. Oh, this is supposed to be $0, not 50. Whoops. Okay, I put it correctly over there. The insurance company wants to calculate the expected value payout in order to see if they make profit. So to find the expected value, you multiply every possible value by the probability of the events. So this is the equation. We have $10,000 times 0.001, 5,000 times 0.002, and then $0, which is 0 times 0.997. Okay? And then we find that e to the x is equal to 20. So that means that the insurance company should expect to pay out every customer $20 at any given time. Okay? This means the insurance company is expecting to pay $20 a person per year per customer. Now, we're charging, as the insurance company, $50 per year per customer. That means the insurance company is going to profit $30 per year per customer. And that's pretty good. Like, if they're insuring 100,000 people, that's a lot of money. And this is how insurance companies make money. Okay, so this is another example. I'm sorry that there wasn't any animation on this. So if you have another chart like this, We have our amounts, which is our little x's, and then we have our probabilities, which is our p of little x's. So I have, for example, 10, 20, and 30 are the amounts, and then we have p of x, which is these three amounts here, and we just multiply them up. 10 times 0.02 because they match, 20 times 0.4 because they match, 30 times 0.4 because they match, and then our expected value is 22. This could be very useful if you're talking about any type of predictive models. So for example, if we're talking about insurance policies, if we're talking about, for example, how much money you would take from a quest in a video game, you also could use this in order to figure out like the likelihood or amount of, say, money you would spend if you were to have a child, okay, and what's happening throughout like gestational periods of childs, or also like after a child's birth. But yeah, you guys are gonna have a couple of examples just like this one with charts. I am expecting to see all of your work, so please contact me if you have any questions, comments, concerns, issues. Please, I'd love to see you in the chat. Thanks so much, and I'll talk to you guys soon.